So this says the median, we're just setting up the proof, we're not solving it. The median to the base of an isosceles triangle is an altitude. There's no if or then. There's no if or then. But it says the median to the base of an isosceles triangle is an altitude. So let's just ask ourselves, what do we know to be true? Well, what kind of shape do we have? A triangle. How many triangles? Just one. So here's our triangle. And it says the median to the base of an isosceles triangle is an altitude. So what do I have to draw in this triangle? A median. And a median must start at a vertex. So I'm going to go from B to D. It's not my job to mark anything up. I'm just creating it. So now we have to come up with our given based on this diagram. So it says the median to the base of an isosceles triangle. So what kind of triangle is this? Isosceles. I have to tell the reader that. So we're going to say triangle ABC is isosceles. I can't stop there. What else do I have to tell the reader? Adam. You got it. We're going to say AC is the base. Or I could write base AC, sorry. We could just write base AC. All right, so let's go back and read it again. You notice it's a lot of reading, right? The median to the base of an isosceles triangle is an altitude. All right, what else do we have to tell the reader is in this isosceles triangle? Charlie. Excellent. BD is a median. Now, do you all agree? It's saying the median to the base of an isosceles triangle is an altitude. We need to prove that BD is an altitude. So that's our proof. Prove BD is an altitude. How many people got it correct? Excellent. Very good. All right, so you've been pretty fortunate, right? 4.1, nothing new to memorize. 4.2, nothing new to memorize. 4.3, there is one theorem for us to memorize. There's one theorem for us to memorize. The theorem tells us how we show that angles are right angles without having perpendicular lines or altitudes. How would we show that two angles are right angles? Well, tell me, if two angles are supplementary, what does that mean they have to add to be? 180. Now, those two supplementary angles are also congruent, right? So not only do they have to add up to 180, but those two angles that have to add up to 180 also have to be congruent. What is the only measure that angle can be, those angles can be? 90 degrees. Do you agree? The only way two angles can be supplement and congruent is if they're 90 degrees. All right, so that's basically what the theorem tells us. Let's write it out. You're going to have to memorize this. If two angles are congruent and sup, they are right angles. It is a theorem, so you do have to memorize it. We can't say definition of something because this is a theorem. But this theorem makes perfect sense, right? If two angles are congruent and sup, they are right angles. Let's memorize this. All right, do we want to see how this theorem would work in a proof? Everybody get the theorem down. Okay, so step number 1 is our given. I'm going to go through and see if I can make any conclusions and mark up my diagram. We're starting off with AB is congruent to AC, just marking it. Then we have BD congruent to CD. Now we need to prove that AD is an altitude. In order to prove that AD is an altitude, we have to remember what is the function of an altitude. What does an altitude make? Adam? Two right angles. So if AD is an altitude, do you agree we would need to show angle 1 and angle 2 to be right angles? Now, if I'm able to show angle 1 and angle 2 congruent, all right, if I'm able to do that, and aren't they already supplements? We would be allowed to say that right now, that they're supplements. So if I'm able to show that they're supplements and they're congruent, can I say they're right angles? Absolutely. Based on the new theorem, we can do that. But right now, even though we're allowed to say they're supplements, I'm not allowed to say they're congruent at this point. So how am I going to get these two angles to be congruent? James. Good. Prove triangles congruent. Do you agree we already have two sides? So let's go ahead and say AD reflexive. And then we're going to have triangle BAD congruent to triangle CAD by side, side, side. All right, now I want to go ahead and what do I want to say about angle 1 and angle 2 that they are? Bridget? Yeah, it doesn't matter. The order doesn't matter. We're going to need to say they're supplements and we're going to need to say that they're congruent. But now that the triangles are congruent, can I say that the angles are congruent? Yeah, so step number 4, I'm going to say angle 1 is congruent to angle 2. Who knows the reason for that? Adam. CPCTC. Now that I said that the angles are congruent, I also have to tell the reader that they are supplements. So step number 5, I'm going to say angle 1 is a supplement to angle 2. Angle 1 sup angle 2. And that's just def of sup. Because I was now able to show that angle 1 is congruent to angle 2 and supplement to angle 2, I can now, in my proof, this is your new step, put a star, step number 6, angle 1 and angle 2 are right angles. Yes. Chase. Oh, good. Tell me the reason.
If two angles are subs and congruent, they are right angles.
Good. If two angles are sup and congruent, they are right. So that was our new step. Now that we showed angle 1 and angle 2 to be right angles, can I now say that AD is an altitude? Absolutely. So our last step here, we're going to say AD is an altitude, and your reason is going to be def of altitude. All right, we're going to skip number 2. We're going to skip number 2. And let's go on to number 3. This is going to be a long proof. I'm warning you right now. It's going to be a very long proof. Are we ready? Okay. So I'm going through the given, marking up what I have. So we have that AB is congruent to AD. We have BC is congruent to CD. And now we need to prove that AC is the perpendicular bisector of BD. There's a bunch of things we need to show here. So do we agree for perpendicular we need to show right angles? And if we're going to bisect BD, what do I need to show there?
Congruent sides.
Congruent segments, you got it. So for the perpendicular part, we need to show right angles. For the bisector part, we need to show congruent segments. If AC is bisecting BD, do you all agree I would need to show BE and ED to be congruent? That's the bisector part. Yes? All right. Right now, we don't have that. So let's prove triangles congruent. If we're going to prove triangles congruent, we can try these two triangles, the small ones, or we can try these two over here, right? The bigger ones on the other side. I'm going to tell you neither of those will work. Why are they not going to work? Look at the smaller ones. We have two sides. I can do sides to angles, right? Sides to angles, legs to base angles, and I could do reflexive. But what is that? If I do legs to base angles, oops, I'm still in highlighter mode. So if I do legs to base angles and reflexive, ASS, are we allowed to use ASS? No. Why is this not HL? How do I know it's not HL? Because there's no right angles. Let's go to the other side. So again, we need to get BE and ED congruent. So if we look at the other triangles, once again, can I do legs to base angles over here? I can. Legal. Can I also do reflexive? Again, what is that? ASS. Are we allowed to use ASS? Chase, you said it. What are we doing? A detour. We're going to have to do a detour proof. Does anybody see a pair of triangles we can get congruent? Emily.
ADC and ABC.
You got it. ADC, I'm going to outline it in green. And ABC, which I'm going to outline in red. Okay. So do we agree, looking at those two really big triangles, that we already have two sides? Does anybody see where we're going to get our last piece in getting these congruent? Caleb? You got it. Let's go AC reflexive. And now I can go triangle ABC is congruent to triangle ADC, side, side, side. Now it is your choice. We're doing a detour, right? We need another pair of triangles. Both will work. Would you rather get ABE and ADE congruent, so these sort of bigger ones over here on this side, or do you want to get BCE and DCE congruent, these smaller ones over here?
Smaller ones.
Go with the smaller ones? Okay, they both work. It doesn't matter. Let's go with the smaller ones then. I'll highlight them in yellow. They both work, correct. All right, so if we're going with the smaller ones, does anybody see anything I can see PCTC to help me get the yellow ones? Bridget. The two angles by C. I'm going to call them 1 and 2. So step number 4, I'm going to say angle 1 is congruent to angle 2, CPCTC. Not enough. I have now a side and an angle. What else can I say here for these yellow triangles? James. You got it. I can say EC is reflexive. So step number 5, I'm going to say EC is congruent to EC reflexive. So now I can say those little yellow triangles are congruent. So triangle BEC is congruent to triangle DEC, side, angle, side, SAS. All right. Now remember, we're trying to show that AC is the perpendicular bisector of BD. Can I now help me get the bisector part? Yeah, I can say BE and ED are congruent. For what reason? You got it. BE is congruent to ED, CPCTC. I'm leaving that CPCTC open right now. I'm not closing it up. There's more. So now I'm really zooming this in, and I'm going to erase a little bit to give myself more room. So now we got this segment and this segment congruent. That was the bisector part. We got able to CPCTC. But now if AC is the perpendicular bisector of BE, of BD, wouldn't I also need to show angle 3 and angle 4? Got 1 and 2 over here. Wouldn't I need to show angle 3 and angle 4 to be right angles? Yeah, how will I show that 3 and 4 are right angles? Noah? Well, CPCTC won't make them right angles, but CPCTC will make them congruent. So don't we need to show angle 3 and angle 4 to be congruent and supplement, and then I can say they're right angles? So that's the plan right now. Now that the yellow triangles are congruent, I can say that 3 and 4 are congruent, also CPCTC. So angle 3 is congruent to angle 4, CPCTC. But before I declare 3 and 4 right angles, I also have to say that they are what? Supplement. You got it. So step number 8, I'm going to say angle 3 is a supplement to angle 4. Def of sup. Now that I said 3 is congruent to 4 and 3 is a supplement to 4, can I now declare angle 3 and angle 4 as right angles? All right, who thinks they have that theorem memorized? 3 and 4 are right angles, why? 3 people, not bad, first day. Charlie? You got it. If 2 angles are congruent and sup, they are right angles. All right, so now we showed that we had congruent segments, we showed we had right angles. So our last step, we can now say that AC is the perpendicular bisector of BD. And your reason is just going to be def of perpendicular bisector. All right, we have a few more minutes. I'm going to stop here.